Okay, I'm going to talk a little bit today about insurances when future lifetime follows the deMoivre distribution, or in other words, when future lifetime is uniformly distributed. So I'm going to work off of a CAS problem that I saw in my ASM study manual. It's pretty straightforward, and hopefully that will help to illustrate this concept. So they give us that L sub x, or the number of people alive, or the number of lives left at x, is 103 minus x. Okay, so you know that one person dies each year of the 103, and that x is between 0 and 103. So that tells you that the future lifetime follows a deMoivre distribution, or in other words, that the future lifetime is uniformly distributed on 0 to 103. Okay, and we can graph that if that helps you kind of picture what's going on. So future lifetime, corresponding probabilities. Okay, and our limiting age is 103. So in this problem, they wanted to know the actuarial present value of an endowment insurance, a 20-year endowment insurance on a 45-year-old, okay, and it's payable at the moment of death. So we know, first of all, that that would be equal to the sum of a 20-year term insurance payable at the moment of death on a 45-year-old and a pure endowment insurance. Okay, and the pure endowment insurance is just that you just have to get to that point, and if you reach that point, you get the payment discounted with interest. Okay, so before we get into that, well, I suppose, so then let's say you wanted to, if you wanted to calculate, say, the term insurance first, for example, you could work from first principles and use integration. And you know that this represents, so this is the actuarial present value of, they get, if they die in the first year, they get a payment of 1 discounted back 1 year. If they die at time 2, they get a payment of 1 discounted back 2 years, etc. So we want to take the actuarial present value of that, which is just like the expected value taking into account probabilities of survival. So what we're going to do is we're going to be looking at the product of, we're going to be looking at the sum of the products of all the possible death times, right? All the possible times you get paid between now and 20 years from now, and their corresponding probabilities. Okay, so all the payments that you could get, if the benefit is 1, then all the payments you could get can be represented by b to the t, and their corresponding probabilities, we would use the probability density function for future lifetime. Okay, and then since it's continuous, to sum up the products, to sum up all these products and get the actuarial present value, you integrate from 0 to 20. Okay, and we know that the probability density function would be the product of TPX and the hazard rate, or the force of mortality. So you could do that if you wanted to. I'm going to show you a trick. One kind of cool way to think about it, if you might remember that for future lifetime that follows a deMoivre distribution, the force of mortality is going to be 1 over omega minus x. Okay, so now let's think about that in terms of insurances. If you expect about 1 over omega minus x people to die on average each year, then you make payments of 1 over omega minus x on average each year. Okay, so for example, if you were just looking at whole life insurance for 45, you're making payments of 1 over omega minus x on average every year for how many years? Well, you're at 45 now. Oh, it looks like 40. You're at 45 now, and if your limiting age is 103, you have, what, 58 payments left to go. Okay, so that would be an annuity certain, continuous annuity certain, for 58 years. Okay? Hopefully that makes sense. Okay, and then for term insurance, which is what we need to get the first part of this endowment insurance. Okay? This term insurance, you still expect to make, on average, payments of about 1 over omega minus x each year. But now you're only making them for 20 years. And then for the pure endowment, you already know that this is a payment after 20 years, so it's a payment 20 years from now, if you reach that point. So it's a payment of 1 discounted for 20 years of probability, the probability that you even reach that point, and for 20 years of interest. So this, just like it always is, will be TPX VT. Here it would be 20P45 V20. I guess one thing that I didn't mention would be the deferred insurance. So even let's stick with our 20s and 45s and whatnot. If you wanted to find a 20-year deferred insurance payable at the moment of death on a 45-year-old, okay, so that would be, you still, again, on average have payments of, or you still have payments of 1 over omega minus x, still 58 on average each year. Okay, now you start with a life age 45, in 20 years you're at 65, so you only have 38 more years. So that's an annuity certain for 38 years. Okay, so far we have an annuity certain for 38 years that makes payments of 1 over 58 per year on average. Okay, but we have to discount that back 20 years because we're valuing it here, but we're looking at what happens when you get here. So discounting that back for interest, whatever our delta is, v to the negative delta t, or v to the t. So I can put in 20 for t. Okay, and if you wanted to use this with discrete insurances, with insurances payable at the end of the year of death, you could do that too. Just the annuity certain would be it would not be continuous. It'd be discrete. So I think that's it. Hope that helps. Happy studying.